Hi everyone, I'm Clément. I'm a machine learning engineer specializing in natural language understanding. I'm working for the International Consortium of Investigative Journalists, also known as the ICIJ. I joined in 2023 to connect Datashare to Neo4j. Datashare is our search engine made for investigative journalists. And this session will be about how we use Datashare together with Neo4j and the road of turning unstructured documents into knowledge graph, which can be used during investigations. So before we dive into the technical part, let me tell you a bit about the International Consortium of Investigative Journalists. We are a donor-supported newsroom, which means that we are a non-profit organization, and we are organized as a global investigative journalism network. So we coordinate large-scale collaborative investigations between our 300 members who are investigative journalists located around the world. We investigate broken systems, hoping that our investigation and reporting will impact the world by triggering regulatory reforms and driving social and political change. Actually, you might know us from some of our previous investigations, such as the Panama Papers, Paradise Papers, or Pandora Papers. Technically speaking, these investigations consisted in mining millions of files amounting to terabytes of data. And we mine these files in order to surface links between offshore companies and their shareholders. So navigating such a massive amount of data was made possible thanks to Datashare, our search engine made for investigations. So Datashare is developed and maintained at the ICIJ. It's open source software, and its goal is to help journalists converge towards the information they're looking for inside documents they receive. So using Datashare, they should be able to do so even when the amount of data is massive, typically too large to be read by humans. So here is a glimpse of how Datashare works. So let's say that you're a journalist and you receive files from a source. These documents will often come in many different formats. So you could have emails, PDF, scans of documents, spreadsheets, and so on. And inside these documents, you'll potentially find names of interesting entities. So when receiving these documents, the first things that we will do is to actually add these documents to Datashare. Datashare will extract the text content of the documents using OCR as needed for PDF and images. And then once that's done, you will be able to find to use name entity recognition to extract name of entities inside the documents. Datashare will also make the content of the document searchable, which will allow you to later perform keyword search. So you will be able to search either using keywords like here and find relevant documents, but you will also be able to search using what we call name entity search. Because once we extract the text from the document, so here you can see that we successfully extracted the text content of this image. Datashare also is able to extract all the name entities found in the document. So yes, that's about it. Datashare is really a search engine made for investigation documents. So now that you know a little bit more about Datashare, I will tell you how we've successfully used it together with Neo4j. In 2016, during the Panama Papers, we received leaked documents coming from an offshore services provider. And among these 11.5 documents, a small subset contained information about offshore shell companies and their shareholders. So what we did is to add this document to Datashare. And then our data journalist team was able to identify a subset of document of interest, potentially containing information about companies' shareholder. Then they actually performed ETLs to export the data out of Datashare and actually applied some heuristic to extract the shareholder information from the text content of the documents. After that, they performed a round of fact-checking. And finally, after another round of ETL, the data was imported inside Neo4j to create a graph database called the offshore leak database. So this is the offshore leak database. And this is the kind of information that you find inside it. So as you can see, the offshore leak database lets you keep track of shell companies' ownership and identify the shell company's ultimate beneficial owner. So this is the workflow that we've used in many other investigations, and we were very happy with it because Neo4j made it possible to create a high quality offshore registry. And additionally, Neo4j enabled us to connect the dots between distant entities. However, as you can see, this pipeline involved many custom and ad hoc steps, which had to be re-implemented from one investigation to another. So we ask ourselves the following question. Since Datashare also automatically extracts name entities from documents, can we create a knowledge graph from these entities instead of using custom NER pipelines and heuristics like we did for the OLDB? So as a first answer to this question, we released a new Datashare Neo4j plugin, which creates a graph from Datashare's name entities. So when you are inside Datashare and after you've extracted name entities from documents, the plugin lets you create a graph from the Datashare project page in a single click. Once the graph is created, you should see the number of nodes inside the graph matching the number of entities and documents inside Datashare. After the graph is created, you can use tools such as Neo4j Bloom to explore the graph and find information about it. So here, for instance, we are performing a search similar as the one we've done earlier inside Datashare, but we are doing it in Neo4j Bloom. And as you can see, now we have a graph where documents are connected together through entities of interest. You can also, inside the graph, you can also visualize sender and recipient information for email documents. But more interestingly, now you can also navigate from between entities through documents. And that can be really useful to discover new entities during investigations. So that's the graph created by the Neo4j plugin. So as you could see, this graph is quite raw and simple. There's no direct relationship between entities. The entities are connected together through documents. We also have quite generic and not specific relationship types. You could also see that the graph is a bit noisy because of OCR errors and unresolved NER errors. Additionally, the entities, you could see that the entities were not resolved, meaning that there can be 7 nodes representing the same actual entity same real-life entity. And so this is due to noise, but also due to inherent ambiguity between entities. And so because of noise and unresolved entities, navigating this graph usually requires more time and dedication than a journalist can afford during an investigation. So ideally, we like the plugin graph to be a bit more like the offshore leak database graph, meaning that it should feature deduplicated and resolved entities, it should only focus on the small subset of document and entities of interest. And we also expect the graph to feature rich and specific relationships. And we would like the graph to be precise, validated, and exhaustive. So basically, this is where we currently are. So with our raw and noisy graph, and I'll explain where we'd like to go. So using the plugin graph, we would like journalists to be able to infuse external and a priori knowledge. More specifically, we'd like them to provide knowledge bases containing entities of interest. And using this knowledge base, we'd like to perform local graph entity resolution, which will actually aggregate the duplicated nodes, keep only entities of interest, and map the entity nodes to an ID in the knowledge base. We'll still perform manual validation to fact check that the information is correct. And after that, we'd like to enrich our raw graph to produce a new graph, which is locally rich and precise. And using this graph, the journalist should be able to find all the documents containing entities from their knowledge base. And analyzing these documents should enable them to find new entities that they can later add to the knowledge base to perform new rounds of graph resolution. So this is where we want to go in the future. And yeah, I'll tell you where we stand on that road. We've recently made it possible to connect Datashare to arbitrary machine learning pipeline, which should help us to perform complex machine learning workflows. We've added richer entity parsers to enrich the graph, and we'll keep adding more. We are improving the NER to avoid garbage in, garbage out situations. Local entity resolution and rich entity relationship extraction are also coming next. However, we have some constraint on our road. More specifically, our data is very heterogeneous in terms of file formats and quality, and it also varies a lot from one investigation to another. Scale is also a major concern. Some tasks like entity resolution don't scale well to tens of millions of data points. And scaling cost is also a big issue, as we can't afford running expensive models like LLMs on tens of millions of pages. We also obviously have very high confidentiality requirement, meaning that the data can't leave our servers and we can't use external APIs. And we are a very small team on a budget committed to open source. And that implies that we'd like to avoid using proprietary software. So that's about it. I hope you liked the presentation. I know it was a bit dense. I hope it was clear. So if you have any question, feel free to ask them now. I'm listening.